Okay, shall we? Okay, hi everybody. Thanks for coming. Hello? Hello? Thanks, wow, packed room. I'm very happy to see so many people here because I actually wanted to go to one of the other talks in this slot, and I was like, oh man, they put me up against the machine learning guys. So thank you for coming, and we can all watch the machine learning one afterwards, right? They're recording all of these, so that'll help. That'll make it better. Okay, I'm going to talk about simple API design. I was a little concerned when I read what Martin was going to be talking about in the keynote yesterday, because I thought, oh crap, I'm going to have to rewrite my talk after he probably hits all the points I'm going to make to start with. But actually, it turned into a nice segue for a lot of the things that I want to talk about today. So I think I'll draw some analogies. There'll be some high-level stuff, but don't worry, there's some code coming. This is not all a fluffy talk. There is actually some hardcore coding later in it. But I want to start out with some basics, and these are some things that I think we have a tendency to sometimes overlook, particularly in the Scala community, where, frankly, we have a lot of very, very clever engineers that aren't always necessarily focused on the API design. So I want to start out, actually, you won't ever see a Taoist talk much about Taoism, because part of the core tenet of the philosophy is you wait for people to come and ask, rather than pushing it down people's throats. But in this case, this particular piece of information is very relevant to my talk. So there is a verse in the Tao Te Ching, which is simplicity, patience, and compassion. These three are your greatest resources. Simple in actions and thoughts, you return to the source of being. Patient with both friends and enemies, you accord with the way things are. And compassionate towards yourself, you reconcile all beings in the world. Those three things, simplicity, patience, and compassion, are a really, really good basis for an API. And I'll talk about that as we go on. Okay, so if you're writing a library, let's start out with, I'm going to posit a theory that if you're writing a library, you're pretty much intending that to be used by somebody, even if it's only by yourself again. Otherwise, it's not a library. Otherwise, it's a quick hack that you're putting something together that you can use later. But if it's anything else, then you're actually intending your work to be used and reused, okay? And the most important question you need to answer when you're doing this is, who is my target audience? Who is going to be using this, and how can I make it suitable for those people who are going to be using it? Unfortunately, it's also one of the most commonly missed questions by software engineers. It's too easy to get caught up on the problem and forget about the API, and then you come to the end of your library and you're like, oh, I better put something in front of this now. And that's usually the wrong point to squeeze, the wrong area to squeeze out. If you want to be truly humbled, then I suggest getting into working, and some of you probably already do, getting into working alongside mathematicians and scientists that are doing work that they use Scala for and supporting them for it. These people are amazingly bright, and yet they have almost no tolerance for any of the kind of crud that we normally throw out there as computer science people. They're very focused on a particular task, and they want something that's going to help them fix that task. So actually supporting a subject matter expert is a great way to go to get practice in really good API design. As I mentioned, there is code coming. This is not just a fluffy talk. All right. Oh, by the way, that's a picture of the Who. I had to put something on the slide there. Okay, so design. I think this is where a lot of the API stuff gets derailed, is people don't think about the design of their API. So I promised the camera guy I wouldn't move around too much. But on the left here, this is something that was big in the 90s. I think some of you may remember. There was this idea of like model-driven designs and model-driven architectures. And the idea was you had, behind the scenes, you have your domain object model. And then your GUI was something that could be automatically generated by the machine. Okay, you'd take your database tables and you'd run them through this program, this automated process, and out would pop something truly hideous and unusable, much like the thing on the left there. Okay? And it's no surprise that, and actually it was really kind of I would say this is one of the core ideas behind Web 2.0, is suddenly the idea that design really matters in the user interface of what people actually want to use. Web 2.0, people laugh it off as, gradient fills and rounded corners and stuff, but it's more than that. People actually sat down and said, what is my user experience going to be for this thing? And an example of that, on the left, is an invoicing system that was clearly put together by some kind of model-driven approach. I think we've all used this. Anyone who's ever worked or contracted for Oracle? I hope I'm not going to offend anybody. Hideous system to actually go and use and get your stuff. On the right is one that I use for my business. It's called FreshBooks. It's been properly designed, and it's an absolute joy to use. It's a wonderfully designed system. They don't look that different, okay? If you actually look at them, they both have line items. There's not a ton of difference, but on the right, somebody actually sat down and figured out what they wanted the end user experience to be. And the difference when you're using it is profound. And that's an analogy. The same principles apply in API design. The difference is that your model, your underlying model, whatever it is, the abstract model, should not directly affect the API that you produce, and vice versa. You should decouple them, okay? And that's the problem, is that a lot of APIs that we see right now have been so strongly influenced by the implementation model that's underlying them that it really bleeds through, and it leads to a subpar experience for the people using the API. Okay, so simple versus clever. I think this is probably one of the first ones. A bunch of this, if anyone's ever read it, the picture comes from Lifehacker. It's a great website to read up on, just great ideas that people have. So one of the problems, and we're all tempted by this, I am the same as anybody else. I love people to know how clever I am, okay? And when I'm writing a library, I'm like, this is going to be awesome. It's going to use all this stuff and things like that. At some point, you really have to let go of showing everybody how clever you are in favor of giving them something they can really use, okay? If that means that they might not know how clever you are, then I would humbly suggest go and write a blog post to tell them how clever you are after you've released it, okay? But don't let that be reflected in the API. The API should be targeted and simple to use. So rule number one for me is, if you can be clever in your implementation, great, but never at the expense of simplicity in the API. If you've got to choose one of those two things, go simple, don't go clever. If you could, a master would have both. That's the great thing. If you can do it both ways, then great. If you can't, simple is greater than clever, okay? So let go of your ego. Like I say, if you want people to know how clever you've been, write an awesome blog post about how it's all really clever behind the scenes and stuff like that. But okay, second major mistake in library design. This one's a really good one. So you make, and this happens time and again, you make the mistake of thinking that somebody who's using your library cares as much about that problem domain as you do. And if they did care that much about it, they wouldn't be using your library. They'd probably be writing their own, okay? People don't, when they use a library, they just want something that works, and they want it that works, want it to work quickly. I promised myself I wouldn't be too down on any particular example, but there is one that really backs up my points enormously well. I do not wish to cause offense to anybody in the room, and I know they're trying to sort the problem out. But SBT is an example of a tool that violates a lot of this. I don't care. Who in this room really cares about builds? And it's not just SBT, it's any build tool that I've ever used. Who really stays up nights caring about their builds? Okay. I salute you, sir, for that. I couldn't give a rat's ass about my build as long as it builds, okay? I don't want to spend any more time writing build-related code than I absolutely have to. What I want to do is get the thing building so that I can write the system. And having to understand an abstract model of the build system before I can get it to build is not an acceptable requirement. It's too much. Now, I do use SBT, and that's because it has some pretty damn serious advantages, or it used to, certainly, in terms of build speed and stuff like that. Some of the other tools have caught up now. So it was necessary for me to dive in and learn it at that level. But that's the thing, okay? Never make the mistake that somebody who's using your library cares about that library as much as you do, okay? They really don't. They want it to work, and that's all. Okay, so next thing is the out-of-the-box experience really matters. Has anybody got a Kindle here? Who was impressed by opening the box on the Kindle? And it's a funny analogy, but you see this picture and you're like, oh, there's a plastic sheet with that picture on. You take the plastic sheet off and it's not the plastic sheet. The Kindle's actually telling you what it needs. Everything's right there. It says, I need the cable plugged in. You lift it out, the cable's right there underneath. You can tell it's working already because the display's on. It's a perfect out-of-the-box experience, and that's what people are shooting for. Okay? Does anybody in this room have unlimited time and resources? No? Okay, I'm going to take the laughter as a no. Okay, if you're anything like me, I've got a job to do that's always like, I've got a to-do list that you wouldn't believe, and taking time out to look for a library has to be part of the solution, not part of the problem. If I grab a library and it doesn't work straight away, the first question I have is, do I go any further with it at all? Or am I just going to move on to the next thing? Have I got time? If it's important enough, if I think, yeah, you know, lots of people have said that this is good, I'll persevere with it, it had better work within the first day or two. I haven't got time to spend like a week looking at how to get this thing going. So the out-of-the-box experience really matters. It needs to be slick. It needs to just do something. Even if it's not the full power of the thing, you need to make it work for the 90% case straight away. Okay, documentation does actually matter, okay? I know that there are people who say, well, the type system is the documentation. That's great if your audience agrees with that, and I'm going to come back to that later. I am going to touch on Scala Z, for example, a little later, and you may be surprised by what I say there, but documentation is part of the out-of-the-box experience, okay? Even to the point of just the getting started document. That getting started document is critical, okay? There are very few libraries that you can just load up and know exactly how to use straight away. A quick recipe in a getting started that says, you know, 90% of you are going to want to do this. Here's the 3 or 4 things you need to do to get this going. And you get them rolling. That's important for the API. Most people use an IDE, so this is practical considerations now, okay? And these are often overlooked as well. Now, we have been, how do I put this well? We have been a tolerant community in terms of, up until this point, in terms of working with whatever was available. But as more and more people get involved in Scala, they're going to come in with different expectations. I know when I started, there was no IDE that I could use. Well, there was, but it kept giving me errors in the code that weren't real and stuff like that. So I ended up writing a lot of my code using Vim. I expect that's been the same for a lot of people here. But IDEs have got better now. The thing is, a number of libraries that I use day to day actually don't work very well inside of the IDE. There's various reasons for that. An example, and again, I will come back. I'm not picking on any projects other than to illustrate the points. But if anybody has ever used IntelliJ and imported Scala z._ into a file, the IDE practically becomes unusable. It becomes so slow from trying to figure out all of the implicits that are in scope right now that it's really, really hard to edit that file. It goes into spinning beach ball mode for like 20 seconds at a time. And then it lets you type a few letters, and then it goes into spinning beach ball mode again. I think that's a little better with Scala Z7 because the packaging is better, but the rule there is I never import Scala z._. It makes things too slow. So that's an actual practical consideration that you need to think. Other libraries will produce valid Scala code that compiles fine, but the IDE has trouble with it. The IDEA is another example of this. IDEA doesn't use the Scala compiler. It has its own Scala partial compiler. It builds up an abstract syntax tree of its own. It's pretty close, and they're pretty responsive when you report highlighting errors, but these errors come up a lot, and I can tell you that working with scientists and mathematicians, when they see a whole block of red come up, they believe that their code is wrong. They don't remember to hit the compile button and say, oh, ignore it, it's just IDEA doing this. So that's a practical consideration, that if you're targeting those users, there may be things that you can do in your library that help the type system along enough to make it actually, work well within the IDE. Now, I've had these conversations, and people are very much along the lines of, well, the IDE's broken, they should go and fix it, and they are. But here's the thing, the practical side is, if people see that, it's going to be a barrier to using your API. Okay, that's the truth of it right now. You can say, oh yeah, it's the IDE's fault. It doesn't make a difference to the end user. You don't go to the end user and say, oh, blame the tools, blame the IDE for that. They're not interested, they just want it to work. So that's actually this picture, it's a bit small, but this is a picture of a library that a friend of mine and I are actually putting together right now. It's a front end for Couch. I probably shouldn't say too much because I don't want to promise anything yet. But it's very, very functional in design. It uses monads, free monads all the way through to do the work. The problems that we're finding for people who aren't used to this level of functional programming is the IDE screws up a lot. This is valid code, but you can see there's a big block of red there where the type system inferer or inference has failed in IntelliJ, and it's just like given up. I don't know what this is. And then you get the error, and these are the kind of errors that you often see when you're using things like Scala C. You get an error that you have to be a PhD in type theory to actually understand. It's like, I've got it written down here. It says, type mismatch, expected db to stoop.couch, not inferred A, actual db to unapply tc m0 a0, type mx, type A equals a0, pound m of nothing. So, is there anyone in the room that can explain that to me? Because Miles can, okay. New plan, if you do this, you need to clone somebody like Miles and send them out with your API to explain the errors. That's kind of the answer to that. So yeah, there are some real practical considerations to doing this. And they can be fixed. I mean, these are things that, this is development code. We will not put the final code out in this form. We will provide wrappers with more typing information that make it easier to debug and also probably a lot easier for the IDE to cope with. So this is kind of, during the development cycle. But this is the kind of thing where if we stopped here, this would be a bad API experience for somebody. Okay, what else did I have to say on this, if anything? Okay, that's good for that. Okay, so I've got some Scala-specific suggestions to make, and I'd also be interested in some of yours. The other thing about this, and I think if you talk to anybody who's been doing Scala for a while, there's stuff in here that I may change my mind on next week. It's not a bunch of right and wrongs in Scala. There's things that I've been telling people for the last year that I think is a good idea, and all of a sudden I hit a case where it's like, oh yeah, that really wasn't a good idea. And you just do a complete 180, and you're like, don't do that. That's bad because of this. But there's some Scala-specific stuff in here that may be of use. Okay, so let's talk about operators. Operators are tricky because we can do this. Operator overloading in other languages has got a very bad reputation over time, particularly from C++. I'm really happy that we have this in Scala. It's not operator overloading, I should say. It's symbolic method names coupled with infix notation, which does sidestep a lot of the arguments, particularly when you can say that to somebody. But the result is, you say, no, Scala doesn't have operator overloading. It has symbolic method names and infix notation. Totally different. But actually, there are cases. Now, operators are not wrong. They just need to be relevant to your audience. That's the key. Okay? Give a mathematician big decimal in Java, and they look at you like you're on crack or something. It's crazy. Why would you do .add, .mult, all of that? That's a bad API experience for somebody who's a mathematician used to using plus and times and things like that. But the fishbone operator in SBT is still one that I cannot remember. I mean, I look at that and it's like, it's the fishbone operator. What is that? That's insert a bunch of things into the settings using several settings that I pass into the function that it's going to set those things. And I'm like, yeah, that's a lot to parse right there. Also, another one is the what I call the spaceship operators in Scala Z, where it's, or Scala Z. I see that's the American in me coming out, where it, it's like actually kind of makes sense. It's applying this thing across that number of things in a tuple, right, Miles? Something along those lines? Yeah. And the number of stars is relevant to the number of parameters you've got coming into this thing. But the fact that I just had to explain that to you probably tells you something about that. I mean, that's the thing. So one of the things I like to do, this is an actual recommendation, is provide standard English aliases to operators. Let the user decide. Okay, so if you use an operator, provide them with another alternative. It can be an inline def. I've got an example of that later in the code. But if you use an inline def, there's no cost to it, but they can then choose whether they want to use the operator or whether they're more comfortable using an English statement. Actually, Martin hit on this the other day with fold left as an example. You've got the fold left operator. I happen to prefer actually spelling out fold left. I think a lot of people do. Even though I've heard Martin say many times why the fold left operator is a great idea, and I can hear all those, I still prefer the other form. Other ones are things like add and append and stuff like that. Sometimes it flows better if you provide that. If you find, and this is a great, I like to have some of these kind of rules to myself in there because they force other considerations that you might miss otherwise. If you find that it's really hard to provide an English alias to your operator, the chances are your operator is doing too much. Okay, so that, I don't know what we'd call the fishbone operator, the insert into a sequence using some parameters. That's a pretty long operator name. That I would look at in a DSL as an opportunity to split that operator up into several different things. Okay, I'm just riffing here, but maybe to have something like using these items, so the word using, and then a bunch of parameters, insert into seek, and then give it a thing. And all of those could be operators, but the point is that each of them has a one word alias to it, and it's one operation, it's one concept coming at you. So that's a possibility. Let's see, what else have we got here? Here's an example. This is from SubCut. Originally I was going to talk about SubCut, but as you'll see, I've got a few slides in there. SubCut's like 5 minutes or 2 minutes to explain. It's not worthy of a full-length talk, so I thought I'd go for something that was actually based around the ideals that I wrote it with. So here's an example. The tilde is the merge operator. So this lets you take binding modules, things with configuration in them, and just merge them together. So you say use this configuration first, and if that doesn't have anything that matches, use this one, and then this one, and then this one. And I provided, because the tilde, it's reasonably well known because of parser combinators, for example, where it kind of means the same thing. It's like an and then in the parser combinator. And I think I've seen it in a few other libraries. But because of that, I also provided, actually it was called then originally, and then in Scala 2.10 then became a deprecated, soon-to-be keyword. So I changed it to and then. But you can write it either way. You can say module 1 and then module 2 and then module 3. Or you can say module 1 tilde module 2 tilde module 3. OK, so there's an example of them in use. This is another one. This is actually from that couch library that we were talking about. Has anybody seen... Oh, I should not move because... But has anybody seen this? Anyone know what that means in Scala Z? Yep. No? Oh, sorry, I saw a hand up. That's a flat map. And it actually, I don't hate that operator. Like when I've seen it a couple of times, I'm like, yeah, it's kind of mapping to flat. But the thing is, somebody Well, it kind of is, right? It's two arrows and then you've got a pancake. So you're kind of mapping it and flattening it at the same time. I can go with that. My brain works this way, okay? I'm into mnemonics. And if I can actually look at it and put it into something that I can compartmentalize, then I can use that operator. That's my problem with Fishbone, is I've never been able to put that thing into a compartment where I can remember what it does. So here's an example, and what we're doing here is this is actually taking, it's a monad over something called a CouchDB that we keep. It's a free monad pattern. It keeps rolling the CouchDB forward. The idea is that you can do a bunch of operations against the database that isn't there. And then at the end of it, you just keep composing these operations on the database together. And then when you've got the whole thing done, which hasn't really done anything, then you give it a database, and all of a sudden it goes, oh, great, and it goes bang, 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 bang through the list. Okay, and all of those are flat maps, one after another. That is very difficult to explain to a scientist who has come from a Perl background and is used to doing bioinformatics work. Okay, just trust me on this. I've had this conversation. People are like, but they're mathematicians. They're going to understand category theory. No. There's maths, then there's this little corner of maths called category theory, and most mathematicians don't have any more idea about category theory than we did when we came in from the Java world. Okay, so expecting them to learn that stuff is hard. Now, I'm not crazy about this next one. This is a bit of a risk, and this is one of those things that we're doing. And I keep waiting for it to seem like a bad idea, but I haven't yet. This is very, very tentative, maybe a bad recommendation. Warning made. You can actually, by using the apply operator as an alias to that, you can get rid of that. Okay, so what we've done here is actually taken flatmap and made it the default through using apply. And it leads to a fairly nice API that you can kind of explain to somebody. You're sort of saying, oh, I keep moving. Sorry, camera guy. Let's use the pointer here instead. Where is it there? Basically, this is still doing a flat map here, but it's been aliased through apply. And now it says, well, with the items from this invoice, and the items are now available. Okay? And it looks more like the loan pattern, if you've seen that in Scala. And that's a lot easier for people to grasp and get a handle on. In fact, most of the scientists that we work with have already got the hang of the loan pattern, and they love it because it takes all of the problems of like closing files or closing transactions out of their hands, and they're just like, oh yeah, I just want this thing and I want to use it. So, not sure on that one. I'm happy to take comments either now or later. If anybody's got a reason why this is a terrible idea, yes? If you have two flat maps, things get a bit gnarlier, but actually what we end up doing a lot of the time with these is nesting these. And then it looks a bit more natural, so you end up with actually nested things one inside of another. There's a few more tricks that we've used to kind of get that working at the end. And I also think that this is not something that will survive all the way through to the final API. So it's kind of an out there thing that maybe you haven't considered. But certainly using apply to eliminate operators altogether, it's a tool in your toolbox that is something that's pretty neat. The best operator is one that isn't there, I guess is what I'm trying to say with that. If you can eliminate it altogether and make the code read really well without it, that's one of the tools that you can use. Okay, so simpler and better. I'm going to show you a bunch of different examples. It's worth noting that all of these are valid in Scala, and just to set your mental frame, all of these could end up in the same file in Scala. Just imagine being somebody coming into Scala and seeing this code for the first time and seeing all of these in one method to understand how bewildering it can be. So let's have a look at this one. This is some pretty hardcore Scala Z or Scala Z. This is that UFO or flying saucer operator. And that's applying the arguments A and B and coming out with a C. There's another one here. This is the Chelsea bun operator, as that's what I've heard it referred to as. Chelsea bun is it's a nice thing. It's a little pastry that you get in England. That it's like a whirl, like that. Now, what it's actually doing is, I can kind of explain it, is the pipes down the side mean that there's things that are actually contained on either side of that. And what you want is the things that are inside of that to do the operation on. The operation in this case is undefined. That's what the at means. It means it's an operation that I'm going to fill in later. And so what you actually do is you do that. It's the, you can satisfy that with pluses or times or whatever you want to later on. You fill in the function that's going to be used there. Am I right? Miles is here to type check me as I go through this. I'm sure, raise your hand if I make a mistake, because it's entirely possible. All right. So this is something called dispatch. Has anybody used dispatch? Dispatch is another one of those that I don't really hate, but I do get the feeling that some of the operators were kind of gratuitously thrown in there. I'm not sure how much value they really bring. But it is kind of neat. I can see where the author was trying to go with this, which is that the whole API and the operators is meant to look like a URL, okay? And it kind of succeeds and it kind of doesn't. For one thing, you can't have : // right? Because as soon as you got 2 slashes, that's a comment for the rest of the line. So that doesn't work. It can only be a : so that's one thing. The way that question mark is done with the kind of inserter question mark, that's a little weird as well. And then the greater than tilde, that's one I can't fit into a nice mnemonic anywhere. It's like, you just have to remember that. So that's one. I would have liked for that a written alias, an English name alias for the greater than tilde there, to just say, do, or, well, not do, because that's a keyword, but, with this thing, do. Something like that, to actually have an alias that makes sense to me. Because that's what it's doing. It's going to that API with the query parameters there, and then it's passing in the result of that into the function that you give it to do work with. So that's how that's working. So that's dispatch. This is SBT. Actually, I lied when I said you'd see all of these in one. Actually, I suppose if you were really tortured, you could see all of these in one method. It would have to be an SBT script where you were using Scala Z and dispatch in the SBT script. But, stranger things have happened. So this one is the fishbone operator using this is the launch sub, actually the dependency class path. Oh, I'm missing a bit. That's not complete. There we go. That's the dependency class path for launch subcompile and the compile launch subcompile and streams. Then they're mapped into this thing, and then you get those 3 things named again, and then those 3 things used. So that's actually not just a bit complicated to parse for somebody who's just trying to get their stuff to build, but it's also kind of violating the DRY principle. That we're naming and renaming these things a bunch, and that's kind of awkward. Okay, so now we've got a nice bit of Scala test. Now, Scala test is a nice example because this is what I recommend when people say, I want to use Scala on my project. Generally, what I say is, why don't you start by writing your tests in Scala? It's super low maintenance. It's a much better testing language than Java is. Java's a horrible language to write tests in. It's very, very verbose for that kind of thing. It flows nicely, and the best thing of all is you can write really crappy code and it never goes out to production. So it's a great way to learn Scala without the risks. So that's one. And then the final one here is the DSL for SubCut, which is just to bind a particular type to an implementation of that. And it's just bind the data server to single new MySQL host and port. So all of those are, valid Scala. If you saw all of those in one method, you'd probably think that it was just like, and you were new to Scala, you'd probably think that it was just complete anarchy. And oh my God, what have I got into? Sorry? Oh, Perl. Yeah, well, yeah. We actually taught one bioinformatician who got all excited halfway through the course and said, "This is amazing," he said. "This is so cool. Scala is the new Perl." And I'm like, yeah, I don't think we're going to be using that in our training recommendation quotes. Whilst taking the training, the Escalate training, we discovered that Scala is in fact the new Perl. Yeah, not one that we're shooting for. But anyway, yeah. So there's quite a lot of quite a lot of things there. So let's see, was there anything else I wanted to say about that? So of these, I think I'm gonna choose a few of. Actually, no, I'm gonna wait. I have slides coming up for that. Okay, so this is an example of SBT again. This is when you're, there's a bunch of things here. These are, and my SBT knowledge, I know Josh, is Josh here? Josh is like my go-to guy for SBT stuff when I'm stuck. It's handy having a Josh around. He's another like Miles for type checking. You want a Josh around when you're doing SBT for stuff. We need to clone these guys and just send them out as part of the API. But there may actually be quite a better way to do this, but one of the things that's really common in a build tool is you want things to happen in a certain order. Okay? You can't deploy a jar to the server before the jar has actually completed building. And SBT has a strong emphasis on parallelism, which is good most of the time. Okay? It's a good default, but it doesn't have an easy alternative, at least not a particularly easy one, when you want things to happen in a specific order. And the best I've found is where you do things like the dist and the dist local there, where you have to say, well, I want clean and dist package to run, but I can't do the dist package until the clean's finished. So I actually have to have those happen in a certain order. And I have to provide a function that actually does one and then the other explicitly in order to get that to work. What I really want there is just a do in order or something, complete these tasks in the order that I give them, wait for one to finish before going on to the next one, and the semantics would probably be, if one of them fails, don't go on to the next one. That would be that's fairly low-hanging fruit for, improving the overall experience of using these things for buildings. So there's a thought experiment. A couple of other things that, I do think that I need to look at the new DSL. I know that the DSL for SBT 0.13 has been improved and simplified a lot less operators and stuff like that. That's going the right way, definitely. But I wonder, this is Gradle code, and I've never loved a build tool, and I still don't love any build tools that I've ever come across. They're a tool that needs to work to get the job done. But Gradle seems to have at least kind of hit the right note of it's declarative what we're doing. And who cares whether it's functional or not? It's a frickin' build script, okay? My build script doesn't need to be functional, okay? I want to spend those neurons making the rest of my code really functional. The build script, it either works and builds something or it doesn't work, okay? And we know the result of that at the end of it when the thing either deploys and runs or it doesn't. So I'm okay with not everything in the world being functional. I think this was where Martin helped me out a little bit with his talk, because I thought I would be lynched by this point. But now that Martin said it, I feel a little bit more confident to be able to say that myself. So that's one. Another one is, what's this one called? This is Pants. This is the Twitter development thing, and it's all based on Python. And again, it's very declarative. And I think this is what you want in a build tool. It's like, I just need somewhere to say, look, here's the structure of the thing. Here's roughly what I want you to do with it. Go and make it happen and don't bother me with any of the details. Okay, it shouldn't be that involved. Okay, so let's talk about cheating. And this is where I think Martin gave me a wonderful segue in one of the comments on his slides, which was places to use mutability, and he said a bunch of them for performance, and then he said one of them, I think it was for style purposes. And that was a beautiful segue to this, because I think this is actually a valid example of using mutability somewhere where it improves style with very, very little risk. In fact, as far as I can tell, no risk. So this is the way that you define a binding module in SubCut. Okay, SubCut uses a very simple DSL that just says, for this type, when I ask for it, do this thing that gives me back one of those. Okay, and the mutability, or the reason I did this is there's a function that takes a mutable binding module. It takes a loan, so kind of the loan pattern going on here. It takes a loan of a mutable module that's been created, and that gives me a really simple DSL. And here's the thing. I can write a simpler DSL with something mutable, than I can with something that's immutable and purely functional. The problem is when you start chaining a bunch of things together, you need something to connect these things if it's a purely functional builder. Okay, once you get past a few lines, you've got to have some kind of operator saying, well, you've got to keep going. The next change is going to do this, and then the next change is going to do this. Whereas what I really want is just something that reads like a script. It's like, okay, do this thing, do this thing, do this thing. That's mutable. That's all side effecting when you do that. But by putting it into a function that goes into the constructor of this thing, I know I'm not going to get any problems with race conditions. What pops out of this code is completely immutable. Okay? It's just a convenience. It's a completely manufactured simplification for the purposes of this. Oh, wow, I've got to move on a bit. I've been waffling. So anyway, there's an example of using that kind of cheating. Okay, so I promised you I could do SubCut in 5 minutes. I'm going to do that now. Why did I write SubCut at all? There's the cake pattern. There's other well-known, kind of well-documented ways of doing dependency resolution or configuration in Scala. And one of the things you'll find is that everybody says these are really simple and then proceeds to talk about them for well over an hour about how simple it is. And, oh, but there's a few things, you know, the cake pattern has some real issues. I think the best thing about it is its full compile time verifiability, and you don't need any Scala libs or any extra Scala libraries. There's a lot of boilerplate, or, well, not a lot, but there's a fair amount of boilerplate still. The build speed can really be affected when you start using cake heavily. The IDE support and integration is not super duper either. It's hard to kind of navigate through the code, or it can be hard to navigate through the code. That's a practical consideration. And, you know, how many articles are needed to convince you that it's simple, that sort of thing. So, okay, let's do SubCut in, oh, sorry, I went too fast. SubCut in very, very quick time. This is kind of the recommended way. This is in the Getting Started document. You create some binding keys. These are just typed binding keys. I used to just use strings for these, but by making them actual objects, you get a certain level of type safety. More importantly, though, you get help from the IDE when you're using these things, and that's a practical concern that actually people really like. You create a new binding module. This is where you get loaned the binding module. We're using the binding keys here. You just do, this is the mutable bit, so you just do a nice little DSL that says bind the database to this thing, bind a session to this thing. You can provide, you know, apparently instances. There's a lot of stuff going on behind the scenes that's completely hidden from you. I've been quite clever. Really? I'm telling you now because you won't see that in the API. There's a lot of stuff going on behind the scenes that is just totally hidden. And you don't care, and it's tested. So it should work pretty well. I think I'd have heard by now from people, enough people are using it that I'd have heard if there was something amiss in there. Using it, you get to keep your new operator. This is one of the reasons I wrote SubCut, is I hated losing new in dependency injection. I want to be able to create new things. What it actually does is it just passes this configuration round, which is immutable at this point, as an implicit parameter into everything that needs it, and then it can look up these things. And by doing an optional inject, you actually never get the problem of binding not satisfied because it has a default to fall back on. I'm actually in the process of writing SubCut 3, which I can do because I decoupled the API from the implementation. I've gutted the implementation and rewritten it without breaking existing code. Another advantage to actually decoupling those. And the new one is actually based on type classes, which I've rather become smitten with. And it's a much better implementation, and there's a few new features that kind of make it easier to use and more in line. And then the payoff is when you're actually testing with it, you get to do this. You just get to say, right, I've got my standard configuration, but I want to change some of the bindings. So you modify the bindings, you change a few things, mock out a few things, you create the new instance of the thing, and everything runs as it should. No matter how deep in the functional hierarchy you go, if you ask for the database, it's going to give you back the mock database that you put in there. And this is all thread safe. You can have tests running in parallel, you know, all over the place, and everything's isolated so they don't crosstalk, they don't interfere with one another. Okay, I'm out of time. Let's go through some examples. I'm going to really shoot through these. Well-targeted APIs. Scala collections is obviously a well-targeted, well-documented API. Very, very highly recommended. I love that one. Spray JSON is the one that actually got me into really understanding type classes for the first time. Not understanding the theory, but seeing the practical side of how they could be used. And it started the kind of the rock slide of this is amazingly awesome. Scala test, I like. It's a very clean, easy to use API. It's actually quite a big API, but the nice thing about Scala test is you've got getting started documents that kind of give you a window into a much smaller world of, well, I'm really interested in just doing behavior-driven development. So I can choose this fun suite, is it, for behavior-driven development? Yep. And some should matches, sprinkle in a bit of those, and I've got a recipe that I can use. And there's all this other stuff, but I'm not really using that. I'm just concentrating on the bits that I want out of it. Scala Z, I like. I think it's a well-targeted library. It's not a library that's targeted for people who are coming from a Perl background and want to write genetics analysis software. But if it's not a badly targeted library, if what you want to do is incredibly functional, and it's, it actually makes a lot of sense. I've just started working through, I'll stick the link in here or whatever, but it's a great, I think that's the problem with Scala Z. It could use a bit more documentation. And actually, I think this nice tutorial, which is based on Learn You Haskell for Great Good, but kind of translated to Scala Z, that's a perfect getting started document that is it should become part of the core offering of Scala Z. Okay, so recap of the main points. Consider your audience. Don't mistake usage for caring, okay? No one cares about this library, they just want it to work. Decouple the implementation from the API. Design the API. Can't be stated highly enough. Don't just slap it on there as an afterthought. Document the API. This one is one of those other ones that has a great catch to it. If you're like, this API is so large, it's going to take me forever to document it. What does that tell you? It tells you your API is too large. Cut some of it out. Get rid of it. If it's not there, you don't have to document it. Make it small, make it targeted, you save work, and you get to document it as well. And keep it simple, stupid. Okay, simplicity is the king. Don't make the trade-off between clever and simple. Always head for simple. Okay, if you can get both, that's great. But go for that. Okay, and that's it. That's a little bit about us. I think I've kind of overrun, but I'm happy to take questions if we're allowed. And if not, I'll take them outside afterwards. So thank you very much.